So we are going to prove our first trigonometric identity. In contrast to the above, we're asked to prove for all angles x, although it doesn't say, it's implied. Now, over here in our specific context in Manitoba, we have a sort of a really rigid format that we use to prove trigonometric identities. That is, we have the left-hand side and we have the right-hand side, and we equate both to the left-hand and the right-hand side. Now, I'm particularly not that fond of this format. It's really too rigid. But what we're going to do is we're going to equate the left-hand side of the equation and the right-hand side of the equation, and we're going to manipulate both expressions. And we're not going to cross over, so what we're going to do is left-hand side, we're going to break it down as much as we can. And then we're going to take a look at the right-hand side. And the right-hand side, we're going to break it down as much as we can. Maybe we're going to build it up. We're going to just try to algebraically manipulate it. And I hope that our last step, we get the left-hand side is equal to an expression, and the right-hand side is equal to an expression. And if these two expressions are the same, we can declare that this equation is an identity. So, I think a really big key is to start, and by identifying or by breaking down the equation. Well, what do you break it down to? You try to break it down into sine and cosine, the basic building blocks. So the left-hand side is equal to tan theta, which is really sine x over cosine x. The right-hand side, now I knew that and I cheated a bit, right? The right-hand side looks like it's a little bit more work. Now I have a few identities for cosine. So really, I need to take a gamble and, right, cosine 2x. I'm going to try to find an identity for that, and I don't know which one I'm going to use. You'll get a flavor for which one you should use, and it'll just become instinct. I think that I'm going to use this identity and see where it brings me. I wish that I had a better answer for you, but that's what I'm going to do. So the right-hand side, I know that 1 minus cosine 2x, I could write as 1 minus 2 sine squared x. Divided by the sine of 2x. Well, the sine of 2x, I can write that as 2 sine x cos x. Now, where am I pulling these out of? My formula sheet. So I'm just going to write 2 sine x cos x. So right now, the left-hand side is pretty simple. The right-hand side still looks vigorous, but I think I can take care of the numerator. So I'm going to write this 1 minus 1 plus 2 cosine, or sorry, I'm going to carry through that subtraction very carefully not to make a mistake. And I'm just going to rewrite my denominator because it feels right. Now, I'm just saying, take a look where our goal is. We're always going to shoot for our goal, where in the numerator we have a sine, and the denominator is a cosine. So I'm just going to simplify the numerator. The numerator simplifies to 2 sine squared x divided by 2 sine x cos x. What we notice is that both in the numerator and the denominator, there is a factor of sine x. So I can cross those out. And what's left in, and we also have a factor of 2. And wouldn't you know it, that I have sine x over cos x. And if I take a look at my left-hand side, that's exactly the destination I want to reach. So I'm just going to write, therefore, since left-hand side is equal to the right-hand side, the equation is an identity. There we have it.